time for this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth.
It's one small step for man, one giant leap for mankind.
Today is a day for mourning and remembering. Nancy and I are pained to the core by the tragedy of the shuttle challenge.
The following program may contain coarse language, adult themes, and bad attempts at humor. Listener discretion is advised.
What is President Trump's goal? What is his vision? He wants to put an American flag on Mars.
Houston, Tranquility Base here. The Eagle has landed.
I am JE_F, also known as A Cosmic Bard over on X. And this is the Lost Wanderer podcast for April 5th, 2026, produced live from Listening Post Studios and simulcast tonight on KLRN Radio. Now, I was born in 1971, which means I grew up in what you could say was the afterglow of Apollo. I was too young to witness the first moon landing as it happened, but not too young to grow up in a world shaped by it. The moon was no longer just a far-off light in the sky or some unreachable mystery from storybooks from years past. It was now a place that human beings had been to. They had walked there. And for a kid staring upward at night, that changed everything. Because when you are young, the night sky does not feel abstract. It feels a little more personal. The moon is not yet a lesson in orbital mechanics or reflected sunlight. It is a wonderment. It is mystery. It is something that seems close enough to touch and impossibly far away at the same time. I think a lot of us grew up in those years carried a bit of the same feeling, whether we said it out loud or not. If people could reach the moon, then maybe, just maybe, the future was still full of miracles. But humanity's relationship with the moon did not begin with Apollo, not even close. For thousands of years, people looked up at that bright, wandering world, whatever it may have been called, and gave it meaning. The moon was a clock before clocks were invented, a calendar before paper, a guide to the seasons, the tides, and ritual life. It found its way in the myths, prayers, stories, and songs across cultures because it was one of the few things every human being in every age could look up at and share. And long before science explained it, humanity had already fallen in love with it. What I think matters most is that the longing came first. Before there were rockets, before there were engines, before launch pads, there was desire. The moon was humanity's first great other world. Not Mars, not stars, the moon. It was close enough to study, bright enough to dominate the night sky, and distant enough to remain seeming forever out of reach. That combination did something powerful to the human imagination. It made the moon feel less like scenery and more like a challenge. Then came one of the greatest turning points in history. In 1609, Galileo turned a telescope toward the moon and saw that it was not a perfect, smooth, heavenly sphere. It appeared to have mountains, craters, valleys, and shadows. It was rough, scarred, physical, real. In one stroke, the moon changed from symbol to place. It stopped being only a heavenly object and started becoming terrain. And this mattered because once the moon became a world, the idea of someday, maybe just someday, going there no longer felt mythical. And maybe this is one of the truest place to begin the story. Not with NASA, not with Cape Canaveral, not even with Apollo. It begins with human beings looking up for thousands of years and refusing to stop wondering. And by the time I came along in 1971, that ancient dream had already become history once. And like a lot of kids raised in the shadow of Apollo, I inherited that feeling that the moon was not something beautiful to admire, it was something even more. It was somewhere we were meant to go. Before we built the rockets to even reach the moon, we did build the stories first. And that may seem like a small thing, but I do not think it is. Human beings rarely go anywhere first with machines. They often go first in imagination, rehearsing the impossible in myths and novels and sketches and dreams. And in the case of the moon, science fiction got there long before science ever could. And when you grow up loving space, you know the feeling. Space is never just facts and hardware. There is emotion. There is longing. It is a strange, beautiful place where engineering and imagination shake hands. For a lot of us, the road to the moon did not begin with a technical manual. It just began with that first simple drawing that you did as a kid. Now, by the 19th century, the moon had already shifted in the human imagination from symbol to possible destination. One of the clearest examples is Jules Verne's From the Earth to the Moon, published in 1865. Verne imagined a group of Americans trying to launch men to the moon from Florida using an enormous cannon. Now, it was wildly wrong in terms of mechanics, but amazingly right in spirit. The moon was no longer being treated as just a distant ornament in the sky. It was being treated as a problem to solve, a destination to reach, a challenge for inventors and madmen and dreamers alike. Of course, then came H.G. Wells with the first Men in the Moon in 1901, another landmark in lunar imagination. Now, Wells was not just writing adventure, he was writing possibility. Yes, the details were fanciful, sure, but the deeper point was serious. Maybe the moon was not beyond us forever. Maybe it was only beyond our current level of understanding. And then, in 1902, Georges Méliès took the dream to film with A Trip to the Moon, one of the earliest great science fiction movies. It gave the world one of the most famous images in movie history, a capsule striking the man in the moon in the eye. It was whimsical, theatrical, and completely unlike real spaceflight. But that almost makes it more important. It showed that getting to the moon was now part of popular culture, not just with the scientists, not just with the scholars, for everyone. The dream had escaped the observatories at night and entered the realm of public imagination. And this is part of the bridge I love most in this story. Before there were astronauts, there were authors. Before launch vehicles, there were illustrators. Before mission patches, there were movie posters and pulp visions and impossible stories told by people who simply refused to believe the moon was forever out of reach. In a way, fiction gave science permission to be bold. And of course, it's easy to laugh now at giant cannons and fanciful moon men, but those stories did something important. They taught people to think of the moon not just as that beautiful thing in the night sky, but all of a sudden the reach to it became shorter. They moved it from poetry into plot. And once enough people start imagining a destination, sooner or later, someone will begin to figure out how to get there. When we think about it, for most of human history, the moon was but a dream. But it was the annals of man and a Cold War that turned it into a deadline. Humanity's desire to reach the moon was and has always been ancient, poetic, and deeply emotional. But the force that finally accelerated mankind toward it was not poetry. It ended up being competition, fear, with a fair bit of national pride. The moon stopped being only a symbol of wonder and became a test of power. October 4th, 1957, everything changed. When the Soviet Union launched Sputnik 1, the first artificial satellite, that small metal sphere did more than orbit the Earth. It shattered assumptions. It announced that space was no longer the realm of dreamers and fiction writers. It had now entered a real arena of technology, of strategy, and a fair bit of prestige. If the Soviets could put a satellite into orbit, they could prove to the world that they possessed not just the scientific brilliance, but rocket power with military implications too. And one simple launch, the space age began, and the stakes changed overnight. But the Soviets were not done. They kept pressing. In January of '59, Luna 1 became the first spacecraft to escape Earth's gravity. Now, it did miss the moon, but really, it doesn't really matter. It proved that human-made machines could break free of Earth entirely. Then, in September of that same year, Luna 2 became the first spacecraft to reach the moon by crashing into its surface. Just weeks later, Luna 3 returned the first images of the moon's far side, revealing a face no human being had ever seen before. Step by step, the moon was being transformed from that distant object of longing into something, a place where machines could touch, take pictures, and approach with intent. And if you were an American watching that unfold, it had to feel like history was moving very fast and not in your direction at all. Once again, this is where the moon changed again. It was no longer just that beautiful orb in the night sky. It was strategic now. It was still okay to admire it, study it, and write about it. But there was more now. The new question was who would get there first, and what that victory would say about any nation that could pull that off. And that political pressure reached its clearest expression in 1961 when President John F. Kennedy told Congress that the United States should commit itself to landing a man on the moon and returning him safely to Earth before the decade was out. Then, in '62 at Rice University, he gave that ambition its most famous voice. We choose to go to the moon. That phrase became immortal. Hell, you hear it at the beginning of this show every single time. But what gives it force is that it was not spoken into a vacuum. It was a declaration made in the middle of a high-stakes rivalry when space was about courage, technology, and national identity all at once. We did not go to the moon for one pure reason. We went because wonder touched rivalry, because imagination touched engineering, because ancient longing collided heavily with modern geopolitics. The space race took a dream humanity had carried for thousands of years and turned it up to 11. But lest we forget, the moon has called to us always. And now history was shouting back. If the space race turned the moon into a national goal, Apollo would turn it into something even more powerful. Yes, machines had touched the moon before, but Apollo hoped to make the moon the most real it had ever been. And I know that may sound odd because, of course, the moon was always real. Galileo had shown its mountains and shadows centuries earlier. Astronomers had mapped it. Scientists had studied it. Writers had imagined stories taking place upon it. But Apollo changed the moon in the human mind. It was no longer just an object to admire, measure, and dream about. And that emotional transformation truly began with Apollo 11. Now, yes, Apollo 8, launched in December of 68, was the first crewed mission to leave low Earth orbit, travel to the moon, and return safely home. Frank Borman, Jim Lovell, and Bill Anders became the first human beings to orbit the moon and the first to see Earth rise over the lunar horizon. That image, taken by Anders, remains, in my mind, still one of the most powerful photographs ever taken. Next to maybe Joe Adele robbing 3 home runs, but I'm a sports freak at heart too. Now, it showed Earth not as an endless world, but as something small, bright, fragile, and alone against the black. Apollo 8 did not land, but it did change everyone's perspective forever. It was the moment the moon stopped being merely that object of the journey and became the place from which we truly saw ourselves. Then came Apollo 11. July 16th, 1969, Apollo 11 fulfilled the goal President Kennedy had set 8 years earlier: to land a man on the moon. Neil Armstrong and Buzz Aldrin descended to the lunar surface, with Michael Collins remained in orbit above them. With Armstrong's first step onto the moon became one of those rare moments in history that feels larger than the century that produced it. Yes, it was engineering. Yes, there was a heavy dose of politics. But it was also theater on a planetary scale. Humanity had looked up for thousands of years and at last touched that thing it had always wondered about. And Apollo continued. 12, 14, 15, 16, and 17, each added to what we know, and I'm not purposely dissing Apollo 13. You should definitely know what Apollo 13 is if you're listening to this show. But they extended stays, improved exploration, and returned more science from the lunar surface. But in the public imagination, the impossible had already been done. The first footprint was an enormous thunderclap. Everything after it, however important, lingered in that long echo. Now, Apollo 17, launched in December of 1972, when I was nearing my second year on this planet, became the final lunar landing mission of the Apollo program. It was the last time human beings traveled to the moon. And it was also the first Apollo landing to include a trained geologist, Harrison Schmitt. But after that, the trail went cold. No one returned. For more than 50 years, the moon remained a place we had reached, but for some reason, never revisited. And for more on that, catch us in 2 weeks on Juxtaposition, where we might deep dive into some possible theories behind that. Now, there is some strange emotional truth of Apollo. It did not just prove that we could go, but it did leave behind, I think, the most haunting question involving it all: why we stopped. I mean, usually when there's thunder, there's rain, but all we got was the thunder, and then came the quietness of it all. We reached the moon, proved we could, and then stopped. Not because the moon stopped mattering, not because the dream had died, but because history shifted, priorities changed, the machinery of government, money, risk, and public attention apparently moved on to other things. It seemed the moon had become a goal for just one blazing chapter in the book. But once that goal was achieved, the urgency that had driven it began to fade. Now, of course, NASA did not stop exploring space. The years after Apollo turned toward new kind of mission. Skylab, which launched in 73, became America's first space station and shifted attention toward living and working in orbit. I still think they should be called ships, but that's just me. It was a different kind of ambition, less about painting flags on distant ground and more about learning how human beings could survive, adapt, and conduct science in space over longer periods of time. Then, in a little bit of time, came the space shuttle era. The shuttle was revolutionary in its own, a reusable spacecraft designed to carry satellites, crews, and laboratories in the Earth orbit and bring payloads back home. But that is, I think, the key phrase involved all of this: Earth orbit. The center of gravity had changed. Instead of pushing outward into deeper and deeper space, the focus turned inward toward near-Earth operations, orbital construction, satellite deployment, and eventually the long arc that would lead to space stations and international cooperations. And maybe this is part of why so many people of my generation felt that odd ache around the moon. We had grown up with that sense that Apollo had opened a door that we could never touch, never unlock. Surely, we thought, the future would keep charging through it. We would have moon bases, hell, Mars missions, space that felt bigger every year. Instead, the future became dull, more practical, more cautious, and more grounded. Important work still happened, brilliant work, mind you. But the moon no longer stood at the center of the national imagination. That said, the dream did not necessarily die, it just went into hibernation. And that's the emotional truth of the post-Apollo years. Humanity did not abandon space, it simply chose a different path for a while. The moon still remained out there, unchanged and patient, waiting through budget cycles, political seasons, technical setbacks, a few explosions that still triggers all of us from that generation. But we still have generations of children who still looked up and wondered. And here we are now with Artemis. NASA explicitly framing the moon not as just a one-time stunt, but as part of a sustained campaign of exploration that can lead us onward to Mars and maybe beyond. For more than 50 years, the trail was cold, not forgotten, not erased, just waiting desperately to be touched by mankind once more. And for a very long time, getting back to the moon felt like one of those promises the future kept making. We'll get that done, but never really cashing in on the promise. Yes, people talked about it, NASA studied it, dreamers dreamed it, but for decades it remained seemingly out of reach, stranded somewhere between nostalgia and wishful thinking. And then that growing uneasiness, oh, we never went there in the first place, began to grow. But then something changed. For one reason or another, the desire came back. But it did not come back in the same world that has sent Apollo to the moon. The old space race had been a duel between superpowers, with the moon as the ultimate trophy. This new era is messier, faster, louder, and in some to many ways, more exciting. The race returned, but in a different form. This time, it was not just governments seeing who had the biggest wang. It was private industry, new governments, new rivals, and a public once again beginning to believe that going back was not only possible, but now bordering on necessary. NASA's Artemis program became the clearest expression of that renewed ambition. Artemis was never pitched simply as, hey, we're Apollo again. NASA, for all its faults, has constantly framed it as a long-term moon to Mars campaign, a return to the moon, not just as that one-time stunt, but as the next stage of deep space exploration. Artemis I, launched in November 2022, sent an uncrewed Orion spacecraft around the moon and back, proving that the spacecraft, the SLS, and the broader architecture could actually get the job done. It was not a parade, it was a test. But it did matter because it turned the dream of return into hardware, flight, and results. We just wish they tested the toilets then. But at the same time, the rise of commercial spaceflight changed the whole rhythm of the conversation. During Apollo, if America wanted to go to the moon, NASA had to essentially do everything itself or through tightly controlled contractors. In this new era, private companies began moving at a speed and scale that changed expectations. SpaceX, Blue Origin, and others, they did not replace NASA, but they did change the ecosystem around it. Suddenly, space was not just a government program. It was becoming an industrial frontier again. Launch cadences increased. Reusability became real in a completely different way than the shuttle. And public imagination woke up again. Again, the heavens no longer felt closed. They were actually starting to feel a little busy. And of course, we can't forget the elephant in the room, China. If Apollo had been driven in part by the Soviet challenge, and I'd say a very large part, Artemis grew in the shadow of a different rising power. China has openly stated its goals of landing astronauts on the moon by 2030, and Chinese officials have continued releasing updates showing that work is advancing on the major vehicles and systems needed to make that happen. And that matters because it reintroduced something America has always responded to in space. The realization that standing still, it is a choice, but often a dangerous one. The moon was once again becoming a proving ground for national capability, prestige, and long-term intent. And of course, as it always does, politics played a role too. Under President Trump's administration, the White House explicitly called for Americans' return to the moon by 2028 and linked the effort to the broader push to Mars. NASA's own budget language in 2025 also said the administrative priorities were aimed at beating China back to the moon and putting the first human on Mars. Whatever anyone thinks politically, that kind of presidential backing does matter. Big space programs do not happen on inspiration alone. They need money, urgency, and often somebody in power willing to say that reaching beyond Earth still matters. And that is what changed. The moon stopped being only a memory of Apollo and became a destination again. Commercial rockets made the impossible feel active. China has made the stakes feel even more real. Yes, NASA built the framework. Political leadership pushed the goal back into the center of the national conversation, although I would probably give more credit to Elon. And for those of us who grew up staring at the moon and wondering if humanity would ever truly return, that old silence of 50 years finally began to break. We get excited because the dream had not died. It had just been gathering the quiet strength it needed for another run. For years, going back to the moon lived in a strange category of things we all talked about as if they were just around the corner. It was always coming, always near, always planned, always just a few years away. But now, in this moment with Artemis II underway, that old dream is no longer trapped in concept art, policy papers, or speeches by lying politicians. Human beings are once again on the road beyond low Earth orbit. And for the first time since Apollo, the moon is not merely something beyond history. It is ahead of history again. Artemis II is not just a symbolic return to deep space. It is proof that the long silence after Apollo has finally been broken. It tells the world that humanity did not permanently retreat back into the cocoon of low Earth orbit. It tells every kid looking up at the moon that the trial is open again. And maybe more importantly, it tells us that this is not meant to end with just one dramatic lap around the moon and a nice cordial round of applause. Artemis II is part of something larger now. The mission itself is historic, but it is also a bridge. It is the mission between remembering and rebuilding. And what comes next is where the new roadmap gets fascinating to me. Under NASA's current Artemis architecture, Artemis III is no longer being described simply as the next landing. Now it says Artemis III is planned as a demonstration mission, albeit in low Earth orbit in 2027, to test the integrated operations between Orion and one and or both commercial lunar landers from SpaceX and Blue Origin. That is a huge shift in how the public thinks about the sequence, because it shows this time how serious the agency has become about not just rushing to a headline, but actually proving the hardware and docking choreography needed to support future lunar landings safely. In other words, Artemis III is about the testing of the tools of return before we trust them with the full weight of history once more on the shoulders of our brave astronauts. And then will come Artemis IV. And this is where I think the emotional charge really will kick in. NASA said in March of 2026 that Artemis IV is now targeted as the first Artemis lunar landing, hopefully in early 2028. With the crew launching on board Orion and transferring to a commercial lunar lander for transportation to the moon's surface. NASA's broader Artemis and Gateway materials also described Artemis IV as a mission that begins the Gateway era in lunar orbit, using that outpost as part of the architecture for sustained lunar exploration rather than just simple flag and footprints stunts. Gateway is meant to serve as a staging location for lunar surface missions, science in lunar orbit, and later deep space operations. That changes the whole meaning of the moon. We are not talking about just simply visiting again. We are talking about building a system that lets us keep going. And once you start thinking in those terms, the horizon gets bigger very fast. Because if you have landers, orbital infrastructure, repeated missions, and a strategy aimed at the lunar South Pole, then you are no longer just reaching out for the moon. You're beginning the early shape of permanent presence. Not a science fiction moon city tomorrow morning, but the kind of architecture from which moon bases, surface habitats, longer expeditions, and true lunar industry becomes imaginable. NASA's own Moon to Mars planning language is built around long-term exploration of the lunar surface, sustainable operations, and the use of the moon as proving grounds for what comes next. We have to remember the moon is not the final destination in this vision. It is a training ground. It is the workshop. It is a forward camp. And that may be the deepest shift of it all. Apollo was magnificent. It was also, you could say, borderline fragile. It was a burst of glory, a heroic sprint. Artemis, by contrast, can seem a little boring on paper. It's trying to become a system, something way less romantic in the short term, but way more powerful in the long run. A road instead of a single leap for mankind. So here we are. Artemis II has shown that humanity is once again willing to send people beyond low Earth orbit. Artemis III is meant to test the landers that will make future missions possible. And we sit here with Artemis IV now being positioned as the mission that could put astronauts back on the moon, while all keeping our eyes on things further. It is the beginning of a new chapter with a new map in hand. The moon is, once again, a destination, and the road is being built in stages. And beyond it, still waiting in the dark, is everything else. But we should look at the moon not as a destination, but as a doorway, a proving ground for Mars, for deep space, and for that incredible next great chapter of human courage. We are learning to go back not just so we can stand on that silver world again, but one day that we can go further still.
Wakes up.
welcome back. Hope you were able to stretch and get something to drink for that. My overly lengthy opening monologue. We'll get back to the regular programming of Lost Wanderer now. Because after spending that first half talking about the dream of actually getting back to the moon and beyond, we should, well, come back down to Earth for a second, or maybe, actually, I guess technically probably somewhere between the Earth and moon, and ask a very practical question, one that I love asking for every ISS resupply, but we never get the information on. But Artemis II apparently is big enough that we actually do get this information, so we get to ask the question that I love asking on this show. What are the Artemis II astronauts actually eating? Look, if you're young, you may not get it. Our generation grew up on these astronauts, and we grew up on Tang and frozen ice cream. Now, yes, we have South Korean campers with their freeze-dried stuff that we love watching for many reasons, and hopefully our Japanese new friends on X and Twitter will start doing the same thing in more abundance. But food is something, well, it's universal, as our Japanese friends on X have proven to us. We love seeing new creations, seeing new tests and theories of trying for that first time peanut butter on a cheeseburger. So when we get a report that actually contains space eatery, you know I'm going to talk about it. And to their credit, NASA has released everything that apparently they have on board for eating, and it is carrying roughly 190 unique menu items with more than 10 types of beverages, 5 different hot sauces, and some tortilla. Now remember, Orion really has no refrigeration and no fresh food capability, so everything is shelf stable, easy to prepare, and safe to eat in a very small spacecraft. But the menu highlights are kind of great. Here's what we have on the drink side. Coffee. Green tea. Sorry, I've been learning Japanese on the side for different reasons. Mango peach smoothies, chocolate breakfast drinks, vanilla breakfast drinks, lemonade, apple cider, pineapple drink, cocoa, and a strawberry breakfast drink. For flavorings and condiments, the crew gets, well, the first one is because we're carrying Canadian on board for some reason. They're getting maple syrup, chocolate spread, peanut butter, hot sauce, spicy mustard, strawberry jam, honey, cinnamon, and almond butter. Now, of course, those are great supplements, but we're here for the main course, right? So the most common foods aboard Artemis II: tortillas, wheat flatbread, vegetable quiche, breakfast sausage, couscous with nuts, mango salad, granola with blueberries, almonds, cashews, barbecued beef brisket, broccoli au gratin, spicy green beans, macaroni and cheese, tropical fruit salad, butternut squash, and cauliflower. I know. I'm really want to try that barbecued beef brisket. I'm right there with you. Just saying. But let's face it. If you're going to the moon, you're going to want to have dessert as well. And apparently, according to NASA, the crew's sweet options include cookies, chocolate, candy-coated almonds, cobbler, pudding, and cake. I love this. I do. Because in a way, this is part of where the grandeur of spaceflight meets the stubborn reality of being human. We dream in rockets and history and fire and that amazing launch. But somebody still has to pack the quiche. Somebody still has to count the tortillas. Somebody still has to make the most difficult question of spaceflight ever. How much hot sauce humanity needs on the road back to the moon? It's a very important question. Now, NASA says the food system is built around crew health, hydration, nutrition, shelf life, and of course, crew preference. That's why the maple syrup is there, damn Canadians. They're meals that can be ready to eat, rehydratable, thermostabilized, or irradiated, sorry. And the astronauts use Orion's water dispenser and compact food warmer to prepare what they need. Now, they might have a little bit of problem with the shitter off and on, but hey, nobody's perfect. So yes, Artemis II is that historic mission I drawled on about in the Glenn Beck fashion at the beginning of the show, though I do think I did a good job. It is also about the 4 people in a spacecraft with coffee, with brisket, with quiche, cobbler, and 5 different kinds of hot sauce. But it's this, knowing the foods they carry. It's what I've been saying forever, why I need food on resupply missions. It makes the whole thing feel even more real, more touchable, more there. There's only one more thing that I love hearing about more than food in space. And that's sex in space. Because if I said it once, I've said it twice on this program, we need proper studies on having intercourse and the results of sex in space. We cannot ignore this. And I'm willing to, maybe go up on a launch with some of our new Japanese friends and test some theories out. I'm just saying I'm available for experimentation. That's it. Because if humanity is serious about living beyond Earth someday, not just visiting, not just planting flags, normal flags, not what we're talking about right now, and not just taking selfies in, really expensive pants, then sooner or later, the question becomes whether human life can actually begin once we're out there. And according to a new study highlighted this week, it actually may be trickier than a lot of science fiction ever bothered to admit. This is why it's important to study. Once again, any of my Japanese friends and want to help me volunteer and experiment where I can be reached, a Cosmic Bard on Twitter/X. Researchers at a university used a 3D clinostat to simulate microgravity and found that sperm from humans, mice, and pigs still swam, but lost directional ability and low gravity. In simple English, the little fellas can still move, but without gravity, they appear to get lost. And in the study's maze-like test, about 30% fewer sperm made it through to where they needed to go. And mouse fertilization rates dropped by about a similar amount. Just means we have to have more sex in space. That's all I'm saying. So yes, apparently in space, getting there is harder than expected. Now, if you are hearing that as a setup to about 12 different jokes, congratulations, you are alive and a true and loyal listener to Lost Wonder, and I love you. But underneath any innuendo that we could possibly come up with, and I could probably do half an hour on it, space agencies and commercial companies keep talking about long-term settlements on the moon and Mars. Scientists are now finally saying reproductive health cannot stay a policy blind spot if we are actually planning to put people out there for the long haul. A February paper in, and this is real, Reproductive Biomedicine Online argued that as human activity moves from shorter missions to sustained presence beyond Earth, reproduction stops being some sort of weird Barbarella abstract sci-fi idea and actually has to become a practical concern. Someone must have listened to my show 2.5 years ago when I first talked about this. That said, it's not just about sperm navigation. A newer March study also found that embryos formed under simulated microgravity looked fine at first, kind of like that chick at the bar at the end, and sometimes even a little more advanced, but then developed more poorly over time. Researchers think gravity may matter during the first 24 hours of development, when key processes like DNA fusion and epigenetic programming are getting underway. So this is not just a question of attraction, motion, and successful arrival. Even after conception, the environment of space may be messing with the earliest and most delicate stages of life, which means the old dream of someday we'll just have family on Mars may be a little bit more complicated than pop culture has made it sound. Seriously, why have we not been studying this? Because once again, here on Earth, gravity is so constant, we don't notice it. It is background noise. It is assumption. It is the invisible hand guiding us through tides, to walking, to how biology organizes itself. But take that away and suddenly even the oldest process in the human story starts acting weird. And it may be one of the most humbling truths of spaceflight. The farther we go, the more we discover how deeply Earth is built actually into us. Now, of course, none of this means space settlement is impossible. I mean, 30% still means a 70% probability, right? It means the real version is harder, stranger, and more biologically demanding than clean futuristic posters ever showed. I mean, it should be... Sorry, language alert. Just means we're going to have to fuck more. I'm willing to be the guinea pig. We dream first, and then we will discover, all the issues later. So, of course, after talking food, sex is always the afterthought after food, right? Or before food. Either way, they work in tandem. And after sex, typically comes life. At least in theory. And out in space theory, well, it needs a lot more testing. And that kind of leads us to our next question. Maybe, perhaps, the biggest question of all. If making life out there is harder than we thought, where else in the universe might life have maybe a better shot of actually happening? And if life beginning out in space may be harder than we ever imagined, where in the cosmos should we be looking? Because the universe is now full of known worlds. As of this spring, astronomers have confirmed more than 6,000 exoplanets. These are planets orbiting other stars. And that number keeps climbing. But according to a new study led by scientists at Cornell's Carl Sagan Institute, only 45 of those rocky worlds constantly stand out as exceptionally strong targets in the search for life. Out of thousands upon thousands of possibilities, the list has gotten a lot shorter, but a lot more interesting. We are no longer just in the age of finding exoplanets. We are in the age of narrowing the field. The Cornell team used data from ESA's Gaia mission along with NASA's Exoplanet Archive to identify 45 rocky planets in their star's habitable zones, the broad range where temperatures could, as we understand it, under the right conditions, possibly allow liquid water to exist. They also pulled out a tighter inner group of 24 planets that fit a more conservative definition of possible surface habitability. In other words, astronomers are no longer just asking, where be the planets? Yar. They are asking, which of these are actually worth precious telescope time? Like the hot chick in high school that you used to use your telescope to look into the window of? Just me? That was just me? Okay. And telescope time is the key phrase here. Because when you're using something like, say, the James Webb Space Telescope, you do not just get to point it everywhere and hope for the best. You need a target list. You need priorities. You need the cosmic equivalent of a most wanted board for worlds that might actually tell us something profound. And this study is trying to build exactly that. The researchers even grouped planets by which observing methods would work best on each one. Which actually takes us away from that dreamy, there may be aliens out there, guys. to an actual roadmap for how to search intelligently. Did we just get the first sign of intelligence on Earth? I think we might have. Holy crap. Now, some of these names I'm about to mention may sound familiar to space nerds, aka my most loyal listeners. I see you, Ordy and Al. Proxima Centauri B, you may have heard that one once or twice, made the cut for some reason. Even though I tried to delete the data, it made the damn cut. We'll just ignore the fact it's only 4.1927643 light years away. The TRAPPIST-1 system is in there too, including several of the worlds that have fascinated astronomers for years, and planets like LHS-1140b also stand out as prime candidates because they are rocky, intriguing, close enough to keep tempting us with the possibility that one day we might know more about any of them. Now, to be clear, this does not mean any of the 45 planets definitely have life, except for maybe Proxima Centauri b, but just a hunch on that one, guys. It means there are among the best places that Earthlings know where to look. But it should not be understated that that alone is a powerful shift. Because for most of human history, wondering whether we were alone was more a philosophical question. Then it became a bit of a scientific question. Now it is starting to become a scheduling question, a target selection question, a which atmosphere do we analyze first question. And that is a remarkable place for the Earth species to have reached. They are no longer staring blindly into the dark. They are beginning to sort the dark into possibilities. And there is some real wonder here. Doesn't mean they have found aliens, though if they're listening to this podcast, hello, I'm here. It doesn't mean they have found even an Earth 2.0. They have not done that either. But what is happening is people are getting good enough at this to say there, and there. Almost like they're shopping Zillow looking for a house to move into. And that's actually quite amazing when you think of it from that perspective. Now, I do want to take this moment as we reach the 9 o'clock hour for those listening live. There is not a Sunday night with Al tonight. He is taking a night off, much deserved. He has been killing it lately. So I am extending this show by 10 or 15 minutes, so I thank you for staying with me. Now, once you start asking where life might be, there is another short leap that other questions start to crop up. Like why the universe gave matter the upper hand in the first place to put these planets and possible life forms out there. Now, before you get to planets, oceans, biology, and maybe a few confused aliens are arguing over their own tax systems, which suck, you first need matter to actually win. And this is probably one of the weirdest physics parts of the whole equation. By usual rules, the early universe should have made matter and antimatter in equal amounts, same ingredients, opposite charge. And when matter and antimatter meet, they go kaplooey. So if the universe began with a fair fight, then in theory, everything should have canceled out. No stars, no planets, no exoplanet shortlist, no us. Yet, as far as I know, you exist, I exist, living in a universe that seems overwhelmingly made of matter. That mismatch, why said matter won, is one of the deepest unsolved problems in cosmology. But there is a new idea that has come forth, and is exactly the kind of idea this show was built around. A recent preprint discussed by Space.com highlights physicist Nikodym Poplawski's proposal that tiny primordial black holes in the early universe may have swallowed more antimatter than matter. The basic logic is strange, but in a way elegant. If antimatter particles were slightly more massive, they would have also moved a little more slowly in the early universe, making them easier for primordial black holes to actually capture with their gravity. In this picture, black holes did not eat everything equally. They may have preferentially removed antimatter from the cosmic table, leaving matter with the upper hand. Now, if this sounds wild, well, it sort of is. But it's not a random wild. It is aimed at a real problem, and one that this solution actually does make sense with. But the idea comes with a bonus twist. The same primordial black holes that might have helped create the matter-antimatter imbalance could also help explain how some black holes in the young universe grew so large so quickly. That matters because one of the big headaches in astronomy right now is figuring out how supermassive black holes showed up so early in cosmic history. It is like the primordial black holes were we all know Dyson spheres, right? Primordial black holes might have been the Dyson vacuum cleaners that sucked up the antimatter that allowed us to exist. Now, this is, of course, still all speculative proposals. It has not been confirmed by direct evidence. Primordial black holes themselves remain largely hypothetical, and the idea is currently in preprint form rather than settled consensus. Now, Poplawski has suggested that future gravitational wave and neutrino observations could actually help test whether any of this could be real. But even as just a maybe, I have to say, it is a freaking gorgeous, glorious maybe. Because it suggests that the reason anything exists at all may come down in part to ancient black holes acting like a cosmic bouncer at the very beginning of time. So maybe, just maybe, the idea of an intergalactic kegger makes even more sense. And when we put it this way, I'm in love with this theory even more. Now, that said, if you need proof that the solar system still has a metric shit ton of secrets left, look no further than something in our own solar system, Jupiter, where one of NASA's most scientifically productive missions may still be living, but on borrowed time. And that mission, for those that do not remember, is Juno. Because Juno has, well, it was launched in 2011. It started orbiting Jupiter in 2016, and it was originally built to study the giant planet's interior, atmosphere, magnetic field, and polar regions. And even now, after years in one of the harshest radiation environments in the solar system, it is still sending back remarkable science. The problem we've encountered is not that Juno stopped being useful. The problem is that budgets and priorities, well, they don't always give a rat's ass about how fascinating a spacecraft still is. Now, Ars Technica reported in late March that Juno remains healthy and productive even as its long-term future sits under a cloud of uncertainty tied to NASA's science funding pressures. And I have to admit, it would be a shame because Jupiter is still giving us surprises. Juno is still working. Fund it. Make it happen. And one of the newest findings from Juno is that lightning on Jupiter is far more powerful than the kind we get here on Earth. Scientists analyzing Juno data found that some Jovian lightning flashes were at least 100 times more powerful than terrestrial lightning. This is not a minor difference. That is the kind of scale Jupiter specializes. Storms, fields, pressures, and energy so oversized that they make Earth look, well, it makes Earth look quaint by comparison. That said, this feels just right for Jupiter. The biggest planet in the solar system, a world so massive it helped shape the architecture of everything around it. It's actually part failed star, part weather nightmare, part gravitational kingpin. So, of course, its lightning would not be content to merely just, oh, look, that's a pretty lightning storm. It has to show off. But Juno's value actually goes beyond the big flashy headlines. In just the past 3 months, NASA highlighted Juno's results refining Jupiter's true size and shape, showing the planet is slightly smaller and more flattened at the poles than previously thought. Even earlier this year, NASA also highlighted Juno working on Europa, using the spacecraft flybys to estimate the thickness and structure of the moon's icy shell. Let me explain something to those uninitiated with this. In other words, Juno is no longer just quote-unquote the Jupiter mission. It had actually become a broader explorer of the Jovian system, helping us understand the planet, its moons, and the deeper history of the solar system itself. And this is why this story hits a nerve with me. You've already changed Pluto from a planet. Now you're trying to unlock or block history from being found by a still functioning satellite. Because in a sane universe, a spacecraft still making these discoveries at Jupiter would get to keep doing exactly that. But here on Earth, science missions live inside, political calendars. And I don't mean the budget fights and the removal of certain scientists, because what is happening is if political party A says no more, we're cutting science funding, political party B is going to say, we're going to take it from things that actually matter, so makes you look like an asshole, and then political A has to reshuffle the deck, change some things, make some other adjustments, and then political group B makes those same fucking arguments with a different thing. It's all a stupid game. If something is giving us science, fund it. We don't need queer studies in NASA. We need Juno studies studying Jupiter and Europa and the other moons. There, I said it. Probably one of the angriest you've ever heard me on this show. Just fund the damn thing. Now, if Jupiter reminds us that the solar system still knows there are surprises out there, we're going to blow the scale of what we don't know and are studying way wider than what this one was. Because astronomers have just spotted a record-breaking quote-unquote space laser erupting from a pair of merging galaxies nearly 8 billion light years away. Okay, more precisely, it is the brightest and most distant hydroxyl megamaser ever detected, coming from a system called H Atlas J14293.5.3-002836 and picked up by South Africa's Meerkat radio telescope. Now, a quick honesty clause here. This is not a laser in the sci-fi death beam let's blow up Alderaan kind of sense. It is a natural maser, a microwave amplification rather than visible light laser action, produced when hydroxyl molecules in dense gas-rich environments get excited and emit intense radio energy. In this case, that environment appears to have been created by violent mergers between galaxies, the kind of collisions that will compress gas, ramp up star formation, and create the perfect cosmic mess for something extraordinary to happen from. Now, this alone would be cool enough. But what makes this one really sing out louder is that we likely should not have been able to see it clearly at all. Because the signal was magnified by gravitational lensing, meaning a massive object between us and that distant merger bent and amplified the radiation on its way to Earth just, get ready to drink, just as Einstein's general relativity says it should. For those uninitiated with gravitational lensing and Einstein's general relativity, it's like the universe handed astronomers a giant natural magnifying glass and said, hey, look over there. And yes, Deve Mazar is a cosmic mess. Now, all of this matters because these megamazars are more than curiosities. Researchers say They can act like cosmic beacons, helping astronomers study galaxy mergers, bursts of star formation, and even the presence of paired supermassive black holes in colliding systems. And if those black holes are dancing toward each other, then you are also talking about future sources of gravitational waves, meaning this weird radio beacon may help point us towards some of the universe's biggest and most violent transformations. Now, the team behind this discovery has even suggested this object may be so extreme, it deserves a stronger laser than megamaser. Some coverage has even called it a gigamaser, because its brightness and distance blow past previous record holders. The light from this system has traveled roughly 7.8 to 8 billion, with a B, years to reach us, meaning we are seeing it as it was when the universe was roughly half its current age. And that's part of the story that I love really the most. That it's not just a weird signal from far away, it's a message from an older universe, one louder, rougher, and more collision driven than the calmer neighborhood we happen to live in a row. We know those neighborhoods that this happens in, okay? I'm just saying, we all know them. It is a natural microwave beacon born in wreckage, amplified by gravity, crossing half the age of the cosmos, just so one little fucked up species on one small little world could point a radio dish upward and say, well, golly, what the hell is that? And that makes it amazing. Now, as we head out of the solar system, we cannot end the show without properly doing the celestial watch. For those that remember, 4 nights ago on April 1st, the full pink moon lit up the sky and washed the heavens in silver. But now the moon is on the wane. And that is actually very good news for those of us who prefer our stars with a little less glare and a little more mystery. We don't need to know that Hunter Schafer has a penis. The moon will reach third quarter on April 10th at 12:51 a.m. Eastern. Then slide into new moon on April 17th at 7:51 a.m. Eastern. So with each passing night, the sky will grow darker and the deeper treasures of April begin to step forward. In the west, after sunset, 2 bright evening companions are awaiting for you. Not the Japanese kind, because they still haven't returned my DMs. Venus is, of course, the obvious show-off, brilliant and low in the twilight, while Jupiter hangs nearby and remains a fine beacon in the earliest evening sky. Together, they make for an easy and beautiful pairing, much like me, a Japanese girl, and some beautiful sake. One of these sights that asks almost nothing of you, except that you just simply look up at it. And if you're willing to meet the dawn, why? Why would you? But if you're willing to, there is more to be had. Mercury reached its best morning appearance of the year on April 3rd, so the few mornings still offer a decent chance to catch its low in the eastern sky before sunrise, provided you have a good horizon and a little patience. Saturn also begins reappearing in the pre-dawn east around April 8th, low and subtle for now, but back into the game. In the evening, Orion is making his seasonal exit, and this is one of your last good chances to catch the Orion Nebula before it sinks too low into the west. As the moonlight continues to fade, darker skies will also start favoring springtime deep sky objects, including the great globular cluster M13 and Hercules, which is rising by about 9 p.m. Eastern later this week. Then, after new moon, the moon returns not as a bully, but with a whisper. By April 19th, the thin crescent moon will make a lovely pairing with the Pleiades in the western sky after sunset. This should be one of those quietly beautiful little arrangements the sky does so well. A young moon, an ancient star cluster, the evening deepening around them. So that is your sky for the next 2 weeks. Venus and Jupiter in the evening, Mercury and Saturn for the earliest risers, Orion taking a bow, darker nights opening the door to spring, and a delicate crescent moon returning on April 19th to remind us that even after the grandest brightness fades, beauty has a way of coming back softer and somehow better. Until next time, keep your eyes to the skies, not because the heavens need admiring, but they appreciate it. but because now and then they still know how to reward those who bother to look. So that's it for tonight's transmission. Thank you for tuning in whenever and however and whyever you do. Special thanks to NASA, SpaceX, Space.com, Ars Technica, NASA Spaceflight, Popular Mechanics, and everyone out there keeping humanity's eyes on the stars. With me at the helm, the executive producer plotting our next course, and the ship's computer in the back, whispering the star maps through the static. This has been the Lost Wanderer podcast. Until next orbit, I hope you enjoyed the show, learned a little something, and maybe, just maybe, had a laugh or two as well.